The graph is a combined bar and line graph that compares two statistical measures across 4 locations: Delhi, Calcutta, Bombay, and Lucknow. Breakdown of the graph. 1 bar graph, orange bars. Represents root mean square, RMS, values. Delhi has the highest RMS value. Calcutta and Bombay have moderate RMS values. Lucknow has the lowest RMS value. 2 line graph, blue dots and lines. Represents R-squared values. Shows a decreasing trend from Delhi to Lucknow. Key observations. Delhi stands out with the highest RMS value, indicating a significant measure in this context. Lucknow has the lowest values for both RMS and R-squared, suggesting a different performance or result compared to the other locations. The R-squared values decrease consistently from Delhi to Lucknow, which might indicate a trend or pattern relevant to the data being analyzed. This graph could be useful for analyzing location-based performance or results in a specific context. If you have any specific questions about the data or need further analysis, feel free to ask. RMS value, root mean square. RMS value is a statistical measure used to determine the magnitude of a varying quantity. In a management context, it can be applied to various fields such as finance, quality control, and performance measurement. Key points. 1. Consistency and reliability. RMS values help in assessing the consistency and reliability of processes or systems by providing a single value that represents the magnitude of variations. For example, in quality control, RMS can be used to measure the variability in product dimensions, ensuring that products meet specified tolerances. 2. Performance evaluation. RMS values can be used to evaluate the performance of different locations or departments within an organization. Higher RMS values might indicate greater variability or inconsistency, which could be a point of concern for management. 3. Decision making. By analyzing RMS values, management can make informed decisions about where to allocate resources or implement improvements. For instance, if one location has a significantly higher RMS value compared to others, it might need additional support or process optimization. R-squared value. R-squared value is a statistical measure that indicates the proportion of the variance in the dependent variable that is predictable from the independent variable, S. It is commonly used in regression analysis. Key points. 1. Model accuracy. R-squared values help in assessing the accuracy of predictive models. A higher R-squared value indicates that the model explains a larger portion of the variance, making it more reliable for predictions. 2. Performance comparison. Management can use R-squared values to compare the performance of different models or strategies. For example, in sales forecasting, different models can be evaluated based on their R-squared values to choose the most accurate one. 3. Strategic planning. R-squared values can guide strategic planning by identifying key factors that influence outcomes. By understanding which variables have the most significant impact, management can focus on those areas to drive improvements. Practical application. In the context of the graph you provided, Delhi has the highest RMS value, indicating significant variability or performance in the measured context. Lucknow has the lowest RMS and R-squared values, suggesting lower variability and a weaker relationship between the variables measured. Management can use this information to identify areas for improvement, focus on locations with high RMS values to reduce variability and improve consistency. Optimize resources, allocate resources to areas with lower R-squared values to strengthen the predictive power of models and improve outcomes. Thanks.